So now we're going to talk about solving, the last way that you can solve. It's using the quadratic formula, and it is the formula that gives the solutions to any quadratic equation. So you actually could use the quadratic formula every single time. Every single time. You don't have to factor, you don't have to use a graph, you don't have to square root. You could always use the quadratic formula and it will always get you the solutions, okay? Sometimes though, like if you like to use the graph on the calculator, or if you like to factor, or if you like to square root, sometimes when none of those work, you have to, like the quadratic formula is our last resort. So either do it all the time or do it after all of the other options fail, okay? So this is the formula that we're going to use. It's the last way that we can solve. And then we have a thing called the discriminant, which is a part of the quadratic formula. It is the expression b squared minus 4ac, and it's under the radical sign. And I'll point it out when we actually fill in the quadratic formula, okay? So let's keep going. So here is our quadratic formula. And this is the formula. It is x equals, because remember we get answers for x. Now please note you can only use the quadratic formula when it is a trinomial. Okay, so you can only use it when we have two answers, okay? So when the highest exponent is an x squared, or the degree, that's also called the degree, is a 2, okay? So if it's x to the third or anything higher, then we won't use the quadratic formula. This is specific to quadratic equations or our regular trinomials, okay? So it is the opposite of b, plus or minus, that's where we got, whenever we square rooted, we get plus or minus, b squared minus 4 times a times c, and then all of that is divided by 2 times a. Okay? So a basic trinomial, we know that's ax squared plus bx plus c, because we used that when we were factoring. So whatever number b is, we put here. Whatever number a is, we put there, and then c we always put there. So that is the formula that we use over and over again. So you might want to draw a cloud around it. That way you can see it, you can find it, and you're always just going to go back to using it to substituting numbers in for those variables, okay? So that's what we're going to refer to in these problems. So, alright. So here is our first example. So just like we used to do when we were solving, okay, we still want it to say equals 0, okay, because we want that trinomial like we did when we had when we were factoring. So if we don't have that 6, we need to move it over. So we need to subtract 6 over, and that's what we would call standard form, x squared plus 7x minus 6. That way it equals that 0, okay? All right, then I would go off to the side and say, okay, A is what number, B is what number, and C is what number. So A is the number in front of x squared, so that's a 1. B is the number 7, and C is a negative 6. Okay? So always keep the signs with them. So now I just use the formula. The formula is the opposite of B. So if B is 7, that means that when I put it in, I put in a negative 7. Plus or minus b squared, so that's 7 squared. And you could just put 49 there if you want. And then minus 4 times a, which is 1, times c, which is negative 6. Okay, so this is the opposite of b. That's b squared, a, c, and then the denominator is always 2 times a. So that's 2 times 1. And again, I'm just using the formula that you have up above this problem. I can't point to it because it's not on my screen, but it is on your page. So I put in b's, I put in a's, and I put in the c, okay? Then we just use order of operations. Oh, and they have it over here. 1, 7, and negative 6. Okay? All right, so then, they wanted the formula here and then substitute it in. So let me rewrite myself. 1 times negative 6 times 1 So let me rewrite it so that you can see where it's coming from. Sorry. All right, so it is the opposite of b plus or minus b squared a times c times a. Okay, so that is where all of those numbers came from. I just kind of got ahead of myself. Then you actually work it out, okay? I always work inside the root out first. You could put all of this in your calculator. Right? If you put all of this in your calculator very carefully, okay, you get the square root of 73. All right, so 73 is under the square root, and then it's plus or minus -7. It's all over 2, because 2 times 1 is just 2. And in this case, nothing simplifies, because 73 does not have a perfect square. We can't simplify it like we've been doing. So this is as far as it goes. So we do have two answers. One is, it is the radical version, the version that has the radical in it. So let me write that out. -7 plus or minus the square root of 73 over 2. Nothing reduces, okay? But that is a decimal. It's either the, this one is the positive version. So if you were to say -7 plus the square root of 73 and divide that by 2, you get about 0.77. That's a decimal. And then if you do the negative version, so here's the positive version, and then if you do the minus version, if you were to put -7 minus root 73 and then divide it by 2, you would get -7.77 about. So that's what those squiggly lines mean, okay? So we got it into standard form, our regular trinomial. We recognized what A, B, and C are, either side. We took the formula and then substituted. I put 7 in for the B's, I put 1 in for the A's, and I put -6 in for the C. Then whenever you work it out from the radical out. So the radical first, and then that might simplify, and then we might have to reduce or, and that kinds of stuff. But in this case, it worked out because 73 is it. So we could convert it to decimals if we needed. Sometimes it's left just like this. I usually leave it like this, but I guess it depends on what your options are. Okay? So that is just kind of what the formula is and how we use it. So we'll just practice it a couple more times on the other page, okay?